today's problem from LPP, and it is specially from assignment problem of LPP. And the problem is solve the following assignment problem to maximize the cell. Clear? This is maximization assignment problem. Assignment problem generally be given as minimizing type, but this is maximization assignment problem. And this problem is taken from UPSC main optional math paper 2. Right? How to convert it maximization assignment problem to minimization assignment problem? To convert it into minimization type, we subtract all the cost from the highest cost of the table. So we first find the highest cost or maximum cost of the table, and this is given by maximum cost is given by 50. Okay, so we first reduce it, the minimization problem, and here we write minimization table. Minimization assignment table is we calculate all the cost of corresponding cell. We first calculate the first row. This is 15 minus 3. This is given by 12, right? This is given by 11. This is given by 10. This is given by 9. This is given by 8. Because we subtract all the corresponding cost from the highest cost of the table. For the second row, it is 11. The second element is 0. This is 2. This is 8. Now this is 6. And similarly, we write all the cost of the corresponding cell by subtracting this element from the highest cost of the table, that is from 15. We get the table as. So this is minimization assignment table. Now we check each row carefully, either each row contains at least one 0 or not. Clearly in the first row there be no 0. So we say that row reduce must be required. How to reduce row? For the reducing row or to get 0, we divide least element from all the element of this row. Okay, so we get row reduction table or row reduced table as we again draw a table same as above, but we reduce here each row. Here the least element of this row or the first row is 8, so we subtract 8 from each element. So we get here a 4, and this is 3, this is 2, this is 1, this is 0. For the second row there be a 0. So for this row no reduction of this row required. So this row is unchanged. This is 11, 0, 2, 8, 6. Now for the third row there be no 0. So we subtract the least element 2 from each element and getting the result as this is 7, this is 0, this is 1, this is 8, and this is 2. For the fourth row there be a 0, so this is also unchanged. 8, 3, 0, 7, 10, and there be no 0 in the last row, so we subtract 2. This is the least element from each the element. This is 5, this is 0, this is 3, this is 7, and this is 4. Okay, now we check each column, either each column contains at least one 0 or not. Clearly in the first column there will be no 0. Okay, so we make here a column reduction, and column reduction table as reduction table. Column reduction table we draw the same type of table containing 5 row, 5 column. For the first column there will be a list element 4 and we subtract 4 from each element of this column. So this is 0, this is given by 7, this is given by 3, this is given by 4 and this is given by 1. Okay, because 4 minus 4 0, 11 minus 4 this is 7, 7 minus 4 this is 3 and so on. For the second column there will be 3 0. So no reduction of column required. 3 0 0 3 0. Here also a 1 0 appear, so it is unchanged. 2 2 1 0 3. Okay. For the fourth column there will be no 0, so we subtract 1 from each element, and this is 0, this is 7, this is 7, this is 6, this is 6, and there will be a 0, so this is unchanged. 2 10 and 4. Okay, this table is ready for drawing horizontal and vertical table which are minimum in number, but we covered all the 0 of this table, right? That is, we have to draw horizontal and vertical line or dotted line to cover all the 0 of this table. Okay, how to draw minimum number of horizontal and vertical table? We draw first in the first row. This is a dotted line to cover 3 0, 0 0 and 0. Also we have to draw here, this is 0 0 0 here, so we draw this. Also there will be a 0, and to cover this 0 we draw a dotted line. Okay, and we see that there will be no 0 outside the dotted line, but our number of dotted line is 3. Okay, so here number of dotted line is 3, which is less than 5. Less than 5 means order of matrix. Order of matrix, because this matrix is 5 cross 5, so order is 5 and number of line is 3, so this is not suitable to find the optimal solution of the assignment problem. So we have to increase number of 0 in this table. How to increase number of 0? We find the least element among all the element in the uncovered position. Here in the uncovered position there will be 7 2 7 6 3 1 7 2 1 3 6 4. Clearly 1 is the least element, so we subtract the least element from all the element or all the uncovered element of the table, and we add this least element with the element which are in the intersection of the line. Okay, we practically done this process and we draw the next table. Since this is covered element, so this is unchanged. Since this is the element in the intersection of two lines, so we must have to add the least element. This is 1 with 3, so this is becomes 4, and all the other covered element is same 2 0 0, right? And we subtract, this is uncovered element, so 7 minus 1 this is 6, and similarly this is 0, this is 1, this is 6, this is 5, this is 2, this is 0 because it is in the covered position, this is 0, this is 6, this is 1, again this is 3, this is 4, this is 0 because 3 in the intersecting position, these are intersecting position, so we add 1 with the intersection point, and this is 0, this is 6, this is 10, right? And this is becomes 0, this is 0, this is 2, this is 5, this is 3. Now again we draw horizontal and vertical line, but minimum in number. How to draw? We first draw to cover the 3 zeros here. Also we must draw here, there be 3 0. Here we draw another line, okay, and here we draw again one line. So the number of line again 1, 2, 3, 4, 2 horizontal and 2 vertical. Here number of lines, this is equal to 4 less than 5. So we have to reduce again this matrix or this table, okay, and reducing we again draw another table and we apply here the same process. We find first the minimum of uncovered element, which is again 1. So we subtract minimum element or minimum uncovered element from all the uncovered element of this table and add with the intersecting element, okay. So we get 0, this is 5, this is 3, this is 0, this is 0, this is 5, this is 0, this is 1, this is 5, this is 4, this is given by 1, 0, 0, 5, 0, this is 2, 4, 0, 5, 9, and this is 0, this is the intersecting point, so it is 1, and this is also intersecting point, so it is 3, this is 5, and this is 3. Now try to cover with the minimum number of vertical and horizontal line. We draw a line here, again we draw a line here, okay, to draw this, and again we have to draw these two lines, otherwise we cannot cover all the 0. And it is clear that there be 1, 2, 3, 4, 5, 3 number of horizontal line and 2 number of vertical line. So the number of line this is equal to 5 and this is equal to order of matrix, okay. So we reach at the optimal stage. Now we allocate one by one. We first search in which row there be only 1 0, okay. If we write this matrix again in phrase, we write the matrix here 0, 5, 3, 0, 0, 5, 0, 1, 5, 4, this is 1, 0, 0, 5, 0, this is 2, 4, 0, 5, 9, and this is 0, 1, 3, 5, 3, okay. Here this is 1, 2, 3, 4 and 5, and here is A, B, C, D, E, okay. Now we find first which row contains only 1 0. It is clear that this row contains 1 0, so we mark this row first. Sorry, there will be also 1 0 in the second row, so we mark this row first. This is the starting row, and we assign B to territory number 2, okay. Now here in the fourth row there will be only 1 0, so we assign D to territory number 3, okay. Here we write C, here we write E, and here we write A. Now we go to the last row, and clearly this contains also 1 0, so we assign E to 1, okay. Now we have to assign A and E. How to assign A and E? Clearly the first territory is assigned to E, second territory is assigned to B, third territory is also assigned to D. Now here two remaining territories which are given by 3, 4 and 5. Okay, here we see that in between 4 and 5 there will be only 0 in 5 for C. So we assign first this territory and C to 5. Okay, C to 5. Now there will be only one left. This is 4, which is for the A, and we assign here 4, and this is the complete assignment. Now we have to find the maximum cell. How to find the maximum cell? Maximum cell we find from the given table, not from the starting table, because we convert this table to minimizing type from maximizing type. So maximize cell is equal to A to 4. So we assign here A to 4. So this is 6. Originally this is 6. B to 2. So originally this is 15. And C to 5. And originally this is 11. And D to 3. So this is originally it is 15. And E to 1. This is 8. Okay, and adding all of them, this is 21 plus 11 plus 23. So this is 32 plus 23, and this is given by 55. Right? This is the maximized cell of this problem. Very, very important problem of assignment problem. Thank you for watching.